Hello everyone, myself Dr. Siddharth Reddy, Associate Professor of Chemistry, Vardhaman College of Engineering. In this video, I am going to discuss about secondary batteries. Secondary batteries are rechargeable batteries, meaning is reactant could be converted into products. Again, the products will be converted into reactants. That is, the batteries in which the cell reaction is reversible in nature. And examples if we take, first one is lithium ion battery, and second one we are taking the lead acid storage battery. Now we are going to discuss about lithium ion battery, and for that first we should understand about the construction of the battery. On this, if you observe the diagrammatical representation, from that it is very clear that the anode which we are using is lithium carbon, nothing but the carbon which is incorporated into lithium, that will be act as a anode. Next, cathode, lithium metal oxide. Lithium metal oxide nothing but we are taking LiNCOO2, lithiated cobalt oxide, which will be act as a cathode. Electrolytic solution, lithium salt, that is, for example, we can consider LiBF4 or LiPF6, that is lithium hexafluoroborate or lithium hexafluorophosphate. This will be act as a electrolytic solution. Separator, semi-permeable membrane which we are using, which distinguish the parts of anodic area and cathodic area. Now you observe the construction here. Here we are taking that LiNCOO2, which should be act as a cathode. Li, that is lithium carbon, which should be act as a anode. As we are observing in the diagram, the electrons are always flows from what? Anode to cathode. Next, we will discuss about the working. In this, first we should understand about discharging reactions, then followed by the charging reactions. As we know that this is a secondary battery, first we should understand the discharging reactions, which again it really takes place at anode. What is the reaction takes place? Then we should understand the reaction, what is takes place at cathode. First, anodic reaction, as we have discussed, lithium carbon which should be act as a anode. The reaction is lithium gives rise to lithium plus electron. This is, we can call it as oxidation reaction here. And cathodic reaction, here we are taking that Li plus electrons which are released at anode combines with LiN, lithiated metal oxide, gives rise to LiNCOO2, that is Lin plus 1. Why? Because here n moles of lithium combines with what? 1 mole of Li plus electrons. And you observe the net reaction. What is the net reaction takes place? Here we are observing the common terms which will be get cancelled. Li plus get cancelled. Electron get cancelled. Then we observe the net reaction, that is Li plus LiNCOO2 gives rise to Lin plus 1 COO2. Plus here energy should be released. Why? Because as we are discussing, this is a discharging reaction. Next, we'll discuss about charging reactions here. In the charging reactions, here also the reaction takes place at anode, and as well as the reaction takes place at cathode. Here, one thing we can easily understand, that the reaction which takes place at anode, we have to reverse that reaction. That meaning is Li plus electron gives rise to Li. The reaction which takes place at anode during the discharging, the same reaction if you write in the reverse way, that will be takes place at cathode in the charging reactions. And the reaction which takes place at cathode, if you write the reverse of that reaction, that is Lin plus 1 COO2 gives rise to Li plus electron plus LiNCOO2, and this is the reaction which takes place at anode. Now if you write the net reaction, again the common terms which will be get cancelled, Li plus electron get cancelled, then the net reaction is Lin plus 1 COO2. As we are discussing, this is a charging reaction, plus energy gives rise to Li plus LiNCOO2. This is the reaction, this is a net reaction which we are observing in case of charging. Next, if we move to the applications where we are using, if we take the lithium ion batteries, are there here. In so many fields we can use, like some examples we can take smartphones. As we know that smartphones nowadays we are using in different ways. We are using laptops, we can use medical, so many medical devices we are using, power tools we are using, e-bikes, trains, for kids, EVs, electric vehicles, aviation, grid, renewable ESS and portable ESS and heavy duty cars. Like this, we are observing so many applications of lithium ion batteries in our day-to-day lives. We are not just about providing quality education, we believe in all-round development. Thank you.